In this section, we want to work with a particular discrete probability distribution known as the binomial probability distribution, which is a very handy distribution to know, especially for later work that we're going to do in this course. So before we get into what a binomial probability distribution is, we're going to need to know what a binomial probability experiment is, because it's a very particular type of experiment that has a lot of conditions on it. All right, well, an experiment is said to be a binomial experiment if it satisfies these 4 criteria. Number 1, the random probability experiment is performed a fixed number of times. So each repetition of that experiment is called a trial. So you have to have it in place ahead of time how many times you're going to do this particular experiment. Number 2, the trials have to be independent. So one trial outcome cannot affect the next trial outcome. Number 3, for each trial there are 2 disjoint outcomes, which we'll label as success and failure. Right? And for those, we will have to give context. That's the whole point about these, is that we'll give context for what they are. And X is the number of successes in N trials, and we'll have to give context for those as well for this particular script. It's a little bit of a script right there for X. And then the 4th thing is that the probability of success has to be consistent for each trial, which kind of goes hand in hand with independent. The probabilities won't change. They just will be whatever they are. And the probability of success will be labeled with a little letter P, and the probability of failure, which is the complement of success, is labeled with a little letter Q, as in mind your P's and Q's. Okay, so a couple of things. N, P, and Q are going to be numbers, right? So those values should be numerical values that we find. S, F, and X are words, and you can see that X has a bit of a script right here, because X is the hardest one to write. Now, success and failure don't necessarily mean good or bad things. It's not necessarily that success is a positive thing and failure is a negative thing. It all depends on the perspective of the particular problem you're in. So don't get bound up that success is good and failure is bad. It's more look at the problem and figure out what they're trying to figure out. All of this is going to be very important for us in chapters 8, 9, 10, and 11 when we work with polls and surveys, because polls and surveys tend to be binomial experiments. And we'll see how that works later on. All right, so these definitions are a little esoteric, so let's actually look at this in the context of a problem. So we have a student that takes a multiple choice test that has 10 questions. Each question has 5 choices, only one of which is correct. The student guesses randomly at each answer. Explain how this experiment is binomial and identify N, P, Q, S, F, and X. Okay, so to explain why it's binomial, we have to show that it satisfies the 4 conditions up above. So let's look at those 4 conditions. So the fixed number of trials. Well, yes, right? This satisfies that because it has 10 questions, right? N is equal to 10 questions. All right, number 2, are the trials independent? And the answer is yes, right? They're independent because because the student's randomly guessing, each question has no effect on the next question. So each question has no effect on the next question. A lot of that is rooted in the fact that this is a random guess. I mean, in real life, it doesn't quite work like that, but it will for this one because the student is randomly guessing. Thirdly, we have 2 disjoint outcomes. So 2 disjoint outcomes. And this tends to be the hardest one to write out. We have to write what they are. So the answer is yes. So success and failure and X. All right, so success would be, just assuming that the student wants the question correct. So from the student's perspective, they would like the question correct. I'll just write correct here. And failure is that they get it wrong. X is the number of successes, so the number of correct answers in 10 questions, right? So it's the number of correct questions in 10 or out of 10 questions. Or I guess I should say the number correct out of 10 questions. Let me put it that way, just to make this make English sense. The number correct out of 10 questions. All right, now what about part 4? We need the probabilities of success and failure to be consistent. Well, they are, because each question, little p, which is the probability, that's a capital P, of success, is 1 out of 5, because each question has 5 choices, only one of which is correct. So it's a 1 out of 5 chance that you guess it correctly. And the Q, which is the probability of failure, would be the remainder, right? It would be 4 out of 5. They're complements of each other. They have to add up to 1. And it's consistent for each question, right? So these values, P and Q, are the same for each question, for each trial. All right, so we've done the explanation bit, because it was really asking us to do 2 things. It wants us to explain how this experiment is binomial, which we did, right, by going through all this list, and we identified these values. N is right here, success is right here, failure is right here, X is right here, P and Q. We have all 6 values. Technically, usually this is just S, and this is just F, but there you can see how it